Okay. So first question is in the JK flip flop when J is 1, K is 0, it toggles. So no, it won't. It toggles on if J and K both are 1 and 1. J equal to K equal to 1. It will toggle only here. In a mux is a digital circuit that selects one of the several input signal and forward it to the single output line. Yeah, that's why we have 2 to the power in is to 1 mux. In a NAND based delatch, when we write enable input as 0, it denotes the memory hold state. Yes, if enable or clock is in latch, it's yeah, enable is 0, nothing would work. In a positive edge triggered uh, D flip flop, if the D is 1 and the clock signal transition from low to high, Q output is 1. In a D class, if D is 1, the Q signal will go to high. Yeah, this sequential circuit do not utilize feedback loops while combination don't use feedback, sequential use feedback. If we want to implement the minimized expression using two input NOR gates, what will the minimum number of NOR gates required? What is missing here? Well, this is 0, 2, 2, 6, 7, 8, 9, 10. Mhm. This is some of this. Let's minimize it. So it is a B C complement plus 2 is a B A complement D C complement, and I think D is also there. D complement. This will be D complement, B complement. Then 8 is A B C D complement plus 10 is 1 0 1 0. So A B C D B complement D complement. So let's reduce this. From this we will get A complement B complement D complement plus A B C D complement. And from this also we can get A B complement D complement. And if we reduce this also we will get B complement D complement and NOR gate, and yeah, we can write this in another form that would be B plus D to the whole complement, which is basically a simple NOR. So yeah, we can just fed B and D here. Just one thing, do we need to make this assumption कि last time ये हुआ था कि नॉट मेरे पास कॉम्प्लीमेंट अवेलेबल है या नहीं है?
आई थिंक अगर लिखा नहीं है तो अवेलेबल नहीं है। अगर अवेलेबल रहता तो लिखा रहता है इसमें क्वेश्चन में।
ठीक है, then ये B will see. Okay, then this is it. B plus T to the whole complement, so only one NOR gate is required. Then this using JK flip flop, assuming it was initially cleared to 0 and share the output for next 4 pulses. Oh, I don't have. Is this is JK flip flop, right? I have not solved this question. No idea.
Okay, so this one is easier. So what is the issue?
Um,
You
let's
have
look at
to
it. The Q
You have
is,
you have to
sorry.
write the JK truth table if you do not remember, and from that you have to solve.
Okay, let me write the truth table of JK. So that is JK and Qn plus 1. If 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, it will Qn. This is 0, this is 1, this is Qn complement. Yep. What next for pulses? So for the first time, when clock is triggered every time, so K is, this is 0, this is
So
0.
initial, so your J is equal to
Mhm.
uh, Q Q Q naught Q into Q naught ka naught, right? So this will always be one, right?
Yes.
Okay, so J will always be one and K will always be one. So next four clock pulses it will toggle.
Okay. So if it is 0, it will be 1, 0, then again 1, then again 0.
Yeah.
Okay. That's easy. Find the minterms for the given Boolean function, and this is for fourth one. So for this A, B, C, so this can be written as 1, 1 and x x. Just tell me if there is any better way to solve it. So
K
this,
map. If you draw K map, it will be done in less than 30 seconds.
A, B, C, D, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1. Yeah, so AB is this thing.
AB is 1 1, yeah. So A naught CD. So A naught is first two rows
Mm-hmm.
and CD naught is last column, I believe.
Yes,
Yeah.
so these two.
Then B, B, C, not D. So B is uh,
This.
second and third row,
Mm-hmm.
and C, not D is second column.
Yes, okay.
Yeah. So now we can find the indexes.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so 2, 5, 6, 2, 5, 6. Again, 2 is
12,
not.
13, 14, 15.
Yeah, 12, 13, 14, 15. So if we want to design the given minterms using three input NAND gate, what's the minimum number of NAND gates required? Okay, so this is 0, 1, 2, 3, 4, 5, 6. 7 is just not there, which is A plus B plus C complement, complement, complement. Okay, and I think the output of NAND is A, B, C to the whole complement if we have three input. So this can also be written as A, B, C to the whole complement. So yeah, just one NAND gate.
Just one question. How did you direct it? I know the A naught plus B naught plus C naught is correct, but how did you write it directly? What is the
This,
trick? No, no, no. A naught, B naught, A naught plus B naught plus C naught.
oh, okay.
After from 7, you derive the equation directly. So I just
Okay.
wanted to know.
So for 7 we can write like this. This is our SOP form.
Correct.
Now we can convert directly to POS form. So for that we need to complement.
Okay, okay. Got it. Hmm.
If you want to design the given minterm using 2 and 2 is to 1 mux, how many mux are required? So let's say this is our mux, this is controller line, this we have I1, I2, I1, I2, O1. Equation is E complement plus B complement plus C complement or ABC to one complement. So if we see it here, we can I cannot get if we write 1 here and a 0 here, this will output the complement.
See, instead of 0, if you pass B naught in the first multiplexer,
The first, okay.
1 on the I0 and no, no, 1 on I0
Mhm.
and B naught, yeah. So you will get B naught plus C naught output.
Mm, B,
B
why,
naught plus C naught. You see now,
why plus?
because you will not get you will get one input
Oh,
only
okay, okay,
at a
okay,
time.
okay, 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 okay.
Yeah.
But that will also be like B naught plus C, na? Then this.
Huh. Yes, that is
Oh,
also correct. But
okay.
if you solve it will come to B
Yeah,
naught plus C naught. Yeah.
yeah, yeah.
But the issue is, if you write three multiplexer, then also it will be correct.
Yeah, because we don't have this V not readily available, right?
Correct, correct. So technically, two is not the correct answer. Three is the correct answer.
If we write A here or A complement, then this will be A complement, B complement. Oh, wait.
So you can pass A, and you can uh, in the I0 you pass 1, and I2 you pass the output of the first multiplexer. Yeah. So this will become A naught plus B naught plus C naught.
Okay, so we also need one more marks for this. Three is the correct answer. Choose the correct options for what? Oh,
This we have to solve. But I
okay.
think this is straightforward. So
Why is this the case? Like, let's solve.
yeah, we just have to
No,
use the
no, no.
formulas.
So this is A and B XOR C, right? This is not XOR, XNOR actually. B complement C complement B C.
No, this is XOR. This is not XNOR.
Oh, that one is that one a dot?
No, that is across, na. The first one is dot, which is multiplication, and second one is XOR. It's
Oh,
plus is XOR.
okay. And
Dot
X.
is XNOR.
Okay, dot is XNOR. Okay. Fine. Dot. So this is A dot B C complement plus B complement C to the whole complement. If we open it, A B C complement plus A B complement C then to the whole complement. That will be A complement plus B complement plus C. Oh wait, that will be A B C complement to the whole complement and A B complement C to the whole complement. And if we open it, so that will be A complement B complement plus C A B plus C, which is obviously not equal.
Yeah.
Let's go with the next one. Mhm. This is A B complement C plus A complement BC is equal to A B complement C plus A B C complement. So this term is same, but this is not. The second one is also correct. Oh, incorrect. And third one is this AB. Oh, AB complement,
AB, AB complement BC plus AB BC complement.
which this will be a zero. This,
No, no.
well,
How come no? You have
like
to open it, na?
oh, okay. Oh, mm, let's open it. That will be A plus B and B complement becomes C plus A B and B complement plus C complement. So this will be A complement B C plus this will be zero.
AB C complement.
Yes, A B C complement.
So it doesn't match.
It doesn't match. Yeah. The fourth one is so A B complement plus A complement B multiplied by B C complement plus B complement C multiplied by A C complement plus A complement C. So if we solve the first two brackets, that will be this will cancel out. First thing, the second thing will be A B
AB
complement.
complement C,
The second, this
A
will,
complement B C complement.
yeah, this will also get cancelled out. So now this thing plus this thing. So in this case, this first one is also got cancelled out, and the second one is also got cancelled out because of A complement. For the second one, yeah, this will be cancelled out because of the A complement, and for the second one, because of the C complement, it will get cancelled out. So yeah, zero. So in the circuit, D1 and D2 are positive triggered flip flop. Okay, X1 and X2 are inputs of D1 and D2 flip flop. Choose the correct timing diagram for the output. Why? So if clock is triggered, okay. Mhm. So this will be X1, this is X2, and this is X0. So 0 double 1 0. Hmm. You are explaining some way to solve this in Neeraj last.
Yeah, so this is positive edge triggered.
Mhm.
So you just have to check at the rising edge. Initially, for the first option, if you see that Y is changing before the rising edge, so first is directly eliminated.
Yeah, this one.
Yeah.
Okay.
Similar for the third option. Third option is also eliminated.
Mm-hmm.
For fourth option we have to check. Okay. So x naught, that means ki, y will be 1 when x naught and x1 is not equal to x2, right?
Yes, yes, yes.
So at the first rising is, if you see x1 is not equal to x2, for the second option,
Okay.
x1 is not equal to x2, so y is 1, which is correct. For second rising edge, x1 is equal to x2, so that should be 0, so y is 0. So that means this is correct.
Mhm.
For fourth option,
Yeah, here they are same, but
yeah, they are same, but the value is 1, so that is not XOR. That's the incorrect.
yeah. Okay. And we want to implement a circuit that outputs the sequence 0 0 0 well, 0 0, then 0 0, then 1 1, and 0 1, and this is using JK flip flop. So let's use the excitation table of JK, which is Qn plus 1, and 0 0 0 1 1 0 1 1. This is 0 1 x x x x x 1 0.
No, no, your table is incorrect. Uh, the sequence is changing from 0 0 to 0 0, and then 0 0 to 1 1.
Oh, this is just excitation
Acha,
table.
okay, you are writing excitation table. Okay.
Yeah, excitation. Now let me write Qn Q. We have to input. Okay, Q. We write it as Qn Q, or better to QA QA QB
Mhm.
QA plus one QA plus B, value of J, the value of K.
But there will be two J and K. So J1, K1, J2, K2. You have to write.
Uh, okay.
So you can write JK1 plus JK2. JK1 and JK2. You can directly write.
J1 K J2 K2. Okay. So for this we need 0 0 to again 0 0, then 0 0 to 1 1.
No, no, 0 0 to yeah, 0 0 to 0 0, then 0 0 to 1
Yeah.
1. Yeah, correct.
Then 1 1 to 0 1, and 0 1 to 1 0 0 1 to 1 0. So for 0 0 this will be 0x. For 0 1 this will be 1x. For 1 0 this will be x1. This is 0 1 is 1x. So 0 1 this is 1x. So how I'm filling this, like whoever is seeing the recording, just take
Hmm.
this column and this column, and ये दो entries check करो. If this is 0 0, fill the entry from here, take 0x. If this is 1 and 0, so 1 and 0, this is x1, x1, 0 and 1, 0 and 1, then 1 and x, 1 and x. Let's do the same for QB and QB plus 1. So this is 0 0, which is 0x. This is 0 1, then 1x, 1 1, which is x0, and 1 O, which is x1. Okay, so for the J1, we can say uh, it is
For
maybe
J1, you cannot figure out any equation. That's why it's incorrect.
okay. So if we go with, even if we try to figure out, so J1 is your Q1 Q2, right?
So
Q1.
Q1, Q2 both are 0, 0. So for
Yeah,
the same input, we cannot have two
yeah,
different outputs.
yeah.
So
This one.
J1 equal to K2, Q2 is incorrect. So all
Yeah.
options are incorrect except the last one.
Even agar if you want to solve the whole thing, then
Sorry.
if we want to get the equation for the whole thing,
For this particular table, there is no equation possible for J1. For K1, you can directly write 1.
yes, okay.
For J2, for J2, for J2 also there is no possible equation. For K2,
Yes.
for K2 you can write Q1 complement.
For K2, we can write Q1 complement. Yeah, okay. Okay, got it. So consider a D latch constructed using NAND gate. The initial inputs are at T0 is 0. The, the write enable is high. The write enable toggles between high and low every 4 nanoseconds. While the input changes from 0 to 1 and back to 0 every 7 seconds. Okay. 0 to 1 and 1 to 0 every. What will be the output of Q after 20 nanoseconds? So let's write T is, let's create a table, I guess. This is 0 and 4, 8, 16, 20. And the output will be, initially the output is Q. So at 4 it will be again 0. Oh, but yeah, wait.
With table you cannot solve. You have to
Yeah,
write create the graph.
I have to create the
I
graph.
think we have I have also solved this question yesterday. So yeah, I've solved this question yesterday from the different paper.
Okay.
Anyways, it's 8 p.m. and my other live call is there,
Oh,
so I'll
okay.
disconnect. If you if
Okay. Last two questions are remaining. Let's, if you are available, let's do the last one, then will I do that after.
Yeah, sure, no issues.
Yeah.
Uh, Q1, Q2, Q3, and this is D flip flop. So D flip flop is very straightforward.
Yeah.
Whatever is the input,
That is the
uh,
output.
that is the output. So you can write Q1, Q2. You can create column Q1, Q2, Q3.
Q1, Q2, Q3,
So initial value is 1, 1, 1.
1, 1, 1.
Okay, so the next value, the D1 is the value of Q3. So in the next row, whatever is
Mhm.
the value of Q3 will become Q1. So Q3 is 1, so Q1 is also will also be 1.
Yes.
For Q2, uh, the
1 is
value of Q1 and
1.
Q3, and you have to take a note of that.
So
So Q1, Q1, Q3, Q1,
Q3.
Q3 not.
Yeah.
Okay. So Q1, Q2 in the first row is 1, 1. So its value will be 0.
Yeah, this is 0. So Q2
Okay.
will be 0.
Correct. And then is Q3 is Q2. So you can write Q2
Mm.
value directly into Q3.
Q3 is Q2. Yep. Okay.
Okay. So you have to look for the previous row and just uh, do the same thing for next I think 3 clock pulse. So you will get the answer.
Okay, then that's it.
Okay. Chalo. Bye bye.
Bye bye. Thank you. So here Q3 is 0 now, so it will come here. So if 0 goes in, 0 comes out, so Q1 will be 1, 0. Sorry. Then this will be Q1, Q3 complement. So Q1 is 0 now. And if any input is 9, NAND is 0, it will output is 1. So it will be 1 here. So 1 for the Q2. Oh, wait. right? So it will be 1 here. Then whatever is Q2, it will become Q3. So this is case. And if we write it again, so the third round, Q3 comes in here, which is 1. It will be Q1. So yeah, 1. And if I check the Q2, it will be Q1, Q3 complement. So Q3 is 1, Q1 is 1. So output is 0. So 0 goes in, 0 goes out. This is 0. And the same Q2 is passed as Q3. So whatever is Q2, this is it. Like, had I made any mistake? After 3 states, wait, let me write equations for this. So Q3 equal to Q2, Q1 equal to, oh, Q2 equal to Q1, Q2 equal to Q1 plus Q3 from the last thing, the whole complement, and Q1 is Q3 minus from the last का complement. कुछ गलती है क्या इधर? If we go again as 111, so Q3 is Q1, oh wait, Q1 is Q3 last वाला का complement, or no complement. ठीक है, then Q2 is this thing. This is like Q3 and Q1 coming in. So Q1 and Q3 from the last thing is -1, and Q3 is Q2 directly. Q1 is Q3 from the last. Okay.
Yeah, Q1 is equal to Q3.
Q1 is equal to
Q3 plus.
Q3 from -1, like from the previous state.
Yeah.
Yeah. So for Q1 it will be 1, same. For Q2 this will be 1.1 ka complement, which is 0. So yeah, it is 0. Q2 will be same. So even I think the answer has some mistake or something. For every Q3 is basically dependent on Q2. So these two digits should be same. But still, let's go through. So yeah, this is correct. Now we can come again for the second round. So Q1 is equal to Q3 from the past, so it is 0. And Q2 is Q1 and Q3 complement, which is 0.0 ka complement, that is 1. Even we can directly write it as Q3 complement because Q1 is same. So this can be written as this. Yeah. So this is 1 and this is also 1. Then this 1 will come here, the 0 will come here, and the 0 will go here. So if answer is 100, please check. Can someone please check this on Discord or somewhere? Haruni? Yes. Can you please check it on Discord? Or maybe someone who is seeing recording can comment better. Okay, let's do this. Hmm. So let's go and create like this. Like the theme chart, or better to go for 2. This is 2 or 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now the right toggles every 4. So it is initially, let's suppose that this is the rating of this toggles. Plan initial and okay, so this is high at 0 and it toggles at before. So it will go till here, go till here, drop down, go till here, drop up, down, up, and it will go in this. Now while the D changes from 0 to 1 and 1 to 0 every 7 seconds. So initially the D is 0. So this is WE. It's D. So initially D is 0. Go will find a clock pulse here. So it will go 1 and for 2. Wait. And we'll go like this for the time and 2, 4, 6. Wow. Can anyone knows how to do this? I don't
Yeah, even I don't know. Aruni?
like if I directly move it yet to start. Okay.
So I haven't I basic idea.
Mm-hmm.
So when write enable is high, uh,
Mm-hmm.
the output will be as D. When write enable is low, it will hold the previous state. That you know, right?
Okay, so at this time, yeah, at this time, or let me use some different color. At this time, it will trigger. At this time, it will trigger it to change.
Yeah.
Okay,
And
let's do it now. And I think this is it. So initially, it was high.
mhm.
So I think it will toggle at the start itself. D here D is 0. It will
Initially,
toggle here.
and D toggles between
0 to 1. D toggles between 0 to 1 every 6 seconds. Every 7 seconds.
every second, 7 seconds. Okay. But initially D is zero, right?
Yeah,
So
initially D is 0.
so you start from zero itself.
Yeah, it starts from 0 itself. But since the W is high now, so it should toggle, na?
No, it
Or
should not.
no? Okay, then let's go till here because it will hold the state.
Okay.
Now it will toggle up here.
This is D actually. First draw the diagram for D.
Mhm.
First you complete the diagram for D.
So this is 2, 4, 6, and somehow it's 7. It will drop.
At 14 it will drop. Yeah.
For not 15, actually at 15 it will drop.
15.
Yeah, and then I think it will go
Almost
further
starting
on.
14, right?
So that is 0.
Okay.
But I have a like doubt. Like
Now
this
you
this
will come to Y.
this won't come below directly. Right.
Okay.
This won't come down automatically, no? There's something needed to trigger this to toggle.
Yeah, we can come to that. And now come to Y. They are asking about the Q, right? Or right Q. Now we can draw the Q.
Okay. Wait. Okay. Sorry. I thought I understand the DSQ. Sorry, my bad. Okay. This is 15.
What you have drawn is just the clock and
Hmm.
the input.
Input, yeah.
Now we need to come to Q.
Yeah.
So until 8 it's 0, whatever it is, until 8 it's 0.
Until it is 0, yeah.
Yeah, at
Now,
this time it toggles
mhm.
and it keeps or stands till 16. Yeah,
Yeah.
then it becomes down.
It copies this one, right?
Yeah. Then it is stable. Yeah.
So this is 0, this is 1, this is 0. So at the end it also goes 0. Okay. Okay, then this question is also done.
Okay.
Let me stop the recording. This paper is complete.